Physicists study everything that influences how the universe works, from the very slow to the very fast. Ultrafast physics studies phenomena that occur very fast and has undergone a recent dramatic revolution. Scientists use ultrafast laser pulses to snap photos of atoms or molecules undergoing a reaction or a biological process. Using femtosecond pulses, which last 10 to the power of minus 15 seconds, we can measure the dynamics of how atoms or molecules interact. And, using attosecond pulses, which last on the order of 10 to the power of minus 18 seconds, we can study electron dynamics within an atom or a molecule. One important question in this field is how to make a measurement of an attosecond pulse. After all, if these are the shortest things we can produce, then what could we possibly measure them with? One important measurement scientists need to obtain is an accurate spectrum of the attosecond pulse without completely destroying the pulse. If we think of the pulse like a shotgun blast of light particles, called photons, each photon carries a certain amount of energy, and the spectrum is like a record of how many photons the pulse carries at each energy. In my internship, I ran numerical simulations and created mathematical models to improve the resolution of one technique to obtain a spectrum, called time-of-flight spectroscopy. In time-of-flight spectroscopy, the pulse passes through a sample of gas. Some of the photons interact with electrons in the gas and pass along their energy to the electron. This gives the electrons some kinetic energy, which can knock them off their atoms with a speed dependent on that energy. By detecting the electrons with a microchannel plate at a given distance sometime later, we can deduce their speed and therefore their energy. We thus obtain a spectrum of the electron energies corresponding to the original photon energies. So far, my research advisor, Charles Boisson-Boucher, and I have been able to improve the resolution by about a factor of 10, and we will continue collaborating to finalize our results in the near future.